Hi, this is Alex from devstories.eu. Zipline Backtesting Engine, Episode 2 of 7. You set up a simple counter in your trading logic using a global Python variable, and halfway through the backtest, it resets or throws an error. In event-driven backtesting, standard global variables are a trap. To survive thousands of simulated market events, you need a safe way to track state, which is exactly where the Zipline algorithm lifecycle and state management come into play. Every Zipline algorithm requires at least two foundational functions: initialize and handle data. Zipline is an event-driven system. It steps through historical data chronologically, triggering an event for each time slice. The initialize function runs exactly once when your backtest starts. It takes a single argument called context. Think of context as your algorithm's persistent memory. It is a simple Python dictionary under the hood, but it acts as a dedicated namespace. Instead of declaring standard global variables, you attach your state directly to context. If you want to track a specific asset like Apple stock, you look it up and initialize and assign it to context.asset. This ensures the reference survives from the first day of the backtest to the last. Next is the handle data function. This is called every time there is a new market event, such as a new daily trading bar. It takes two arguments, context and data. You already know context. That is where you read the state you set up earlier or update running variables. The second argument, data, represents the current market environment. It is your lens into the simulation at that exact moment. You use data to check if an asset is currently tradable, to fetch its current price, or to request a historical window of prices. Consider a standard dual moving average crossover strategy. In your initialize function, you define your target asset and attach it to context. Inside handle data, you ask the data object for the last 30 days of prices to calculate a short moving average and the last 300 days for a long moving average. You compare the two averages. If the short average crosses above the long average, it's a buy signal. You execute this by calling the order function, passing your context.asset and a target number of shares. Trading is only half the job. You also need to track how your indicators perform over time. Zipline provides a built-in function called record. At the end of your handle data block, you call record and pass it your short moving average, long moving average, and the current price. Zipline collects these recorded values at every step and attaches them to the final performance data frame returned at the end of the backtest. When your code is ready, you have two ways to run it. The first is through the command line interface. You pass your Python script to the Zipline run command, specifying your start and end dates, your initial capital, and an output file for the performance results. This is ideal for automated pipelines or remote execution. The second method is interactive. If you use Jupyter Notebooks, you can use the built-in Zipline magic command. By typing %%zipline at the top of a notebook cell, you define and execute the algorithm in line, passing your dates in capital as arguments to the magic command. The results are injected straight into a local data frame, ready for immediate analysis. Here's the key insight. Zipline forces you to split your algorithm into two distinct objects: context for internal state that you control, and data for external market environment. Respect that boundary and your state management will stay perfectly synchronized across thousands of trades. That's your lot for this one. Catch you next time.